Okay, so we have a lead code here, a medium, and the question asks, given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to the target. If there is no such subarray, return 0 instead. Okay, straightforward question, medium. Let's see what we can do here. First and foremost, let's get the total of our window. And the total here is going to be 0. Next thing we need to account for is our pointers. The first pointer we're going to account for is our left pointer. So let's say let left equals 0. And then let's see what else. We also need to account for, let's see what else we need to account for. Probably the minimal length, so min length. So let's say let min length equals infinity in this case, because what we want to do here, and the reason why it's infinity, is because the minimum length could be 0, so we don't know, but we're going to make sure that it is the highest possible value so we don't have any issues. So followed by next, let's say a for loop, and say the second pointer now is going to be the right side. So left right equals 0, and then, oops, can't spell for, and then right less than nums dot length, and then right plus plus. Cool. That's pretty much straightforward. Let's see what else we can do here. Now let's work with our total. So total is going to be implemented each time we loop through our right pointer. So let's say nums becomes now whatever right is. Cool. That's pretty much good to know. Now let's see what else we need to do here. Now what we need to do is work with our sliding window here. So for this case, we'll use a while loop, and we will check to see if our total is, let's see what our total has to be. Return a minimal length of a subarray whose sum is greater than or equal to the target. So yeah, let's just say that it has to be greater than or equal to the target. And I should probably called the total something else, but regardless, moving along. Now let's get our min length to be the first value that we get from here. So let's see, min, and then we say mat that min, and then let's see, then we say min length, and then we need to work with our window, and our window is going to be the right pointer minus the left pointer plus 1, since arrays are of index 0. Now we need to shrink our window. The way we shrink our window is by saying total. Let's subtract from the total the window length, and we'll say that it is going to be now noms, and then the left pointer, and then increment the left pointer. And now what we end up with is basically the minimum length. So the min length, we should return min length, and then let's run and see what we get here. Okay, and that is because this is 0, we forgot to account for that. So let's quickly fix that. So let's say if min length equals infinity, we will return, oh god, return 0, otherwise we'll just return the min length, and this should work fine now. Cool. So let's break this down a little bit more and why we use this algorithm here. So let's see. So 2 plus 3 plus 1 plus 2, that's 8, and that is greater than 7. So we enter the while loop here, and then what we can do is this is greater than 7. So let's try to find a smaller alternative here. And let's now assign this and then subtract our window. Our window now is become 3, 1, 2, and then we increment our left pointer, and now our window becomes 3, 1, 2, 4. Cool. It is greater than 7, but it's not better. It's still 4 windows, 4 elements in a window. So we don't want that. So okay, cool. Let's enter the while loop again. Let's assign this again, so that's still 4, and then the total becomes um, 1, 1 plus 2 plus 4 plus 3. Cool. That is nice and all, but we could do better than that. And then now the while loop again, still nothing changes here. The window shrinks, and now we're at 4 and 3, and that is indeed 7. So wait, what we end up with now is a min length of 2, just like the output expected it. I hope I explained this well. Let me know if do you have any questions. Thank you.